Hey guys, alrighty, we are going to add to our notebook today and we are going to talk about order of operations, your favorite topic, I'm sure. Okay, so in our notebook, we are going to open up to the table of contents and we are going to add to our table of contents. The next topic we're going to talk about, like I said, is order of operations. So we will talk more about in class tomorrow, like why there is an order of operations. I think that's super important. But for now, I know a lot of students struggle with, just simple math. And then once you're looking at a really big string of numbers, that can definitely be very overwhelming. So we're going to do some practice problems together. We're going to talk about what the order of operations is, and hopefully you will all be fine. So 6 and 7 is where that's going to go. Then we want to open up to page 6 and 7. Label those. I hope you guys are doing this notebook with me. This just helps me stay so organized. I am not an organized person. You guys have seen my desk. This just helps me stay super duper organized. Okay, so in our notes packet that we got from textbook pickup, the next one you should be looking at looks like this. On the other side, we have something like that. Now this is going to fold a lot like the last one where we had that line down the middle and we want the two short edges to meet in the middle so that we get like French doors. But unfortunately, we don't have that guideline. So just going to do the best we can. Okay, and if we want to be super cute, oh no, we don't want to be super cute. We don't want to cut. Cutting would be bad. We would cut through our examples. So let's not do that. I'll just glue this boy in. Right on page 7. On page 6, we are going to do a few other examples, so we're going to leave that blank for now. Okay, so when it comes to our order of operations, we have to do, out of all of the operations that we have, the strongest ones first and leave the weaker ones for later, which makes sense. So the first thing that we have to look for are grouping symbols. So I use G to represent our grouping symbols. So those are going to be parentheses or sometimes brackets, or sometimes if we want to get real cute and fancy, you'll see the little curly Q brackets. Those take a lot of practice to draw and get good at. The next thing that we look for, so when I'm looking at a big problem, so if you kind of preview in here, like a big honking problem like that, you're scanning through the whole thing. It's very unlike reading a story. When you're reading a story, you're just reading from left to right. That's it. In a math story or in a long math string of numbers, you have to look at all of it at once, and you have to narrow in on those grouping symbols, and then whatever in the grouping symbols, then you have to reassess, do I have exponents? Because exponents are the next strongest operator. So then we're going to be looking for exponents, and exponents are those little baby numbers. It could be a squared, it could be a to the third power, but you're looking for those little baby numbers. Now, next, strongest, I'm looking through my string of numbers. I've taken care of those parentheses. I've taken care of those exponents. Then I'm looking for, do I have any multiplication or division? Now, the thing with multiplication and division that's kind of strange is they happen like simultaneously. They happen at the same time. So if I have multiple multiplication or division symbols in there, I must, like a story, go left to right. So at that point, when I only have multiplication, division left, or addition and subtraction left, then I have to go back to the beginning of my number string and go left to right. And whenever I come to multiplication, I do it. And if I come to division, I do it. And if division comes before multiplication, I do it before multiplication. I must go left to right. And multiplication and division can look differently. Sometimes we see the multiplication little dot, but sometimes you see the X. We don't use that too much anymore because we don't want it to get confused with a variable. And then usually what multiplication looks like is really just a number smashed up against a letter. So if you're seeing something like 3x, that is, I just put my pen in. That's multiplication. Now division, we're used to seeing the little bar with the two little dots over top of it, but division could also just look like a big bar. So like a number over another number or a letter over a number, something like that, can also be division. So big divide bar is division. Last but not least, once I've taken care of my grouping symbols and my exponents and all the multiplication and division I have, if there are still operators left, they will only be addition or subtraction. And just like with multiplication and division, I must do these in order from left to right, like I was reading a storybook. So after I finish all the super strong operators and I just have addition and subtraction left, I have to go back to the beginning of my number sentence and go in order left to right. And if subtraction comes before, I have to do subtraction first. Addition and subtraction look pretty normal. I think you're used to what they look like. Okay, so step one is looking for those parentheses. So if we look in here at this example problem, I notice that I have parentheses right here. And inside the parentheses, the only operator that I have is addition. And so I'm going to add those up for the 5. I haven't touched any of the other numbers next. Then I scan through the whole problem again. And the next thing that I notice is I do have an exponent. So right here, the only number that is being raised to the second power is that 5, because I haven't multiplied it to the 4 yet. The 4 is not in it. And so 5 squared is 25. Okay, after that, I reassess my problem. I look at the whole thing all over again. We have the 7 minus 4 times 25 plus 10 divided by 2. We want to look for multiplication and division next, and we have to go left to right. So as I scan through this, I first come across these two numbers being multiplied for 100, and then these two numbers being divided for 5. So we came here and we divided to 5. Okay. So now we're down here and we're looking at 7 minus 100 plus 5. And when I'm just left with addition and subtraction, we want to go left to right. And so we're going to do that 7 minus 100 for negative 93. And then negative 93 plus 5 is negative 88 at the end. Okay, so that's kind of how we work our way through that. We kind of jump around and look at what's important and strongest and do those things first. So, I was kind of over that. Let's try a few more. So let's look at this one here. As I scan through, we have some grouping symbols, and I actually have 2 sets. And so we always have to go to the innermost set. So like these things have a parenthesis, so we're going to start here with the 5 minus 3. And I'm going to rewrite my whole problem because I haven't done anything with the rest of it yet. But that 5 minus 3 is just 2. And I don't really need the parentheses around it anymore because it's just 2. Then I still have the brackets that were around the 4 minus 2. So now I'm going to do those brackets. And again, rewrite the whole thing. And 4 minus 2 is just 2. Now that's smashed up against the 5. So I'm going to leave it in parentheses so that I know it's not 52. It's 5 smashed up against 2, which is multiplication. Okay. So at this point, I don't have really any grouping symbols left. I do have that parentheses, but there's nothing in it to do. So now we're looking at exponents. And if I have any exponents, I should evaluate those. And I notice that I do have an exponent down here. And 2 to the third is like 2 times 2 times 2. So 2 times 2 times 2 is 8. So we're going to have 48 over 8 times 3 plus 5 times 2. And now I don't have any exponents left, so we're thinking multiply, divide from left to right. And so as I go from left to right here, I first encounter division. Like 48 divided by 8 is the first thing I come to, so I must do that first. And 48 divided by 8 is 6. Then I bring down that times 3 plus 5 times 2. And now I just have multiplication, so I'm going to multiply this 6 times 3 for 18. And we can kind of do these at the same time because I think you're good enough. And the 5 times 2 over here is 10 for a total of 28. Oh my gosh, can you see that? Yes, okay. Okay, let's try another one. So we have the big divide bar here, which kind of implies parentheses. Like I should do the full top, I should do the full bottom, and then at the very end, we're going to divide. So there's kind of like implied parentheses. What do they use? Here and here. They're like low-key parentheses. So let's deal with the numerator first. In the numerator, I have that parenthesis there, but there's nothing in it to do. So I don't really need to do anything, but I do have an exponent. So we're going to do that 2 to the 5th. So 2 times 2 times 2, what's that, 8? Times 2 is 16. Times 2 is 32. And let's try using our hands, our brains, and not our calculators or Google. Then I'm going to bring down my minus 6 times 2. Now on the bottom, I don't really have any grouping symbols either because there's nothing to do inside of that 3 that's being parenthesized or whatever. But I do have that exponent, so we're going to do that 3 times 3 for 9 times 3 for 27, and then bring everything else down. Okay, so we can kind of do these simultaneously as long as we don't get too confused. Now again, going back to the top, that numerator, we took care of grouping symbols, we took care of exponents, so now we're looking at multiplication, division. We're going to go left to right, and I only have multiplication right here, so I'm going to multiply those two numbers. So 32 minus 12. On the bottom, I'm at multiplication, division as well, and these two numbers are being multiplied for 15. We're going to have 27 minus 15 minus 2. Okay. Numerator. All I have left is subtraction. So 32 minus 12, we're at 20. Denominator, all we have is subtraction. We're going to go left to right. So 27 minus 15, let's see, that's 12 minus 2 for 10. And then we can divide. And thankfully they divide nicely. Now, if they didn't, if this was like 21 over 10, I'd probably just leave it. If it was 21 over 7, I'd divide that. That's 3. But if it was 21 over 14, I'd reduce it because 7 goes into both. Here, I can divide evenly, and then that's just 2. So, like, if you can reduce, leave it as a fraction. I don't think I'd ever change it to a decimal because, look. Okay, last but not least, we're going to try this one here together. And then I'm going to have you guys try 3 and post a picture of your extra examples. Okay, so as I go through, I notice I have some grouping symbols. So I'm going to do what's in the grouping symbols first. So 4 minus 2 is 2, and I'm going to rewrite the rest of the problem exactly as it is. So I just did the grouping symbols. Then I still have this parenthesis, but there's nothing to do in it, but it is being raised to a power. And I don't have any other exponents anywhere else, but we are going to do that 2 to the 3rd. So 2 times 2 times 2. Was 8. Write everything else down as it is. Okay, so we did grouping symbols, we did exponents. Now we're going to do multiplication, division from left to right. So I start at the left, and I don't stop until I see multiplication or division right here. So I'm going to divide that first. So we're going to divide these two numbers for 2, and then I'll times the 3 after. So I'm going to bring everything else down, and we'll go back here and times. So 2 times 3 for 6. Then I'm just left with addition, subtraction, and so we're going to move left to right again. And we're going to do 10 minus 2 for 8, plus 6 is 14. Now you can be a little bit crazy with addition and subtraction if you want to, but you just have to keep the sign in front. Like if I wanted to, I could do positive 6 and negative 2 for 4, with the 10 is 14, and I still get the right answer. That doesn't work for multiplication and division. If I would have multiplied there first and then divided, I would have got the very wrong answer. So you cannot do that with multiplication and division. Okay, so on page 6, I'm going to write out 3 examples for you to try. And I should say that sometimes, actually at the very top here, sometimes I might have to substitute first. And what I mean by that is you might notice in your problem that you have an A variable or a B variable, but they're going to tell you what those are equal to. And so wherever you see an A, you'll replace it with that number, and wherever you see a B, you'll replace it with that number. So sometimes I might have to substitute first. All right, so we're going to try example 1. We'll do 10 minus 2 to the third plus 4 divided by 3 minus 1. Leave yourself some space. We got example 2, or pause it and try it now if you want. We're going to do brackets, parentheses, 4 plus 2 to the second minus 40 plus 3, and your brackety minus 5. That's an intense one. Okay, and then the last one I'm going to have you try is where you are going to try that little substitute thing I was just talking about. So substitute and evaluate. Evaluate is just a fancy word for find out what I equal. When A is 1 and B is 4, and then your equation, or your expression rather, is going to look like 2 parentheses A plus 3 squared divided by B plus 5. And notice that I did just correct myself there and say expression. You'll notice that nowhere on this paper anywhere, except for right there, did I put an equal sign. Don't use equals when you're doing this. Just move down a line and write your new expression. No equal signs. All right, so try these 3 examples, upload your picture, and we'll talk more about it in class tomorrow.